footing. In this video, you will learn to assign the rebar information, and run analysis and design on the model. First you will change the rebar material for design. Zoom in a bit, and carefully write Design Strip A. In the Design tab, choose the rebar material. Change the rebar material to HYSD 415, and click on OK. Click on OK to exit. Again, right-click on the Design Strip Layer B, and repeat the steps for changing the rebar material. You are almost done with the drawing of the footing model, with the required properties. Now you will check for the load values, which you have already mentioned earlier. Right-click on the center point of the column. Select the Loads tab. You can see that the dead and live load is already assigned by default. Click on OK to exit. Suppose the load values are different, or there are no loads on the point. Left-click on the center point of the column. Check for the selection in the bottom left corner. Go to Assign, Load Data, and click on Point Loads. Choose the option Replace Existing Load, which will replace the already present loads. Then you have to enter the new value in the Gravity, -Z, option, and click on OK. Suppose you want to remove the already present loads completely. Then you have to click on the Delete Existing Loads option, and click on OK. Now the assigned loads are correct, so you need not make any changes. Cancel the Point Loads dialog box. You have changed the rebar material for the design strips, but you have not changed them for the footing and stiff elements. Right-click on the footing area, and go to the Design tab. Change the rebar material to HYSD 415, and click on OK. Click on OK again, to exit the Footing Properties box. Similarly, right-click on the column area, and change the rebar material to HYSD 415. You can verify the rebar by right-clicking on the concerned element area, as shown. Likewise, you can right-click on the design strips too, and check the rebar material. Now you have provided all the given information to the footing model. Go to the Run menu, and click on Run. You will be asked to save the file. Save the file with a suitable name. The software will run analysis on the model. The progress of the analysis can be checked in the bottom left corner. Once analysis is complete, it will display the slab displacements due to the dead load, by default. Which information is being displayed can be seen from the top of the window, as shown. You can notice that the footing is displayed in different colors. Hover your cursor over the colored footing, and the displacement values at the different points are displayed. The displacement value corresponding to the different colors can also be referred from the color code bar on the right side. This bar displays the displacement value in millimeters for different colors. For example, the inner part is red color, which has a value of -6.08. This means the red-colored portion is displaced by a value of 6.08 mm in the downward or gravity direction. The displacement is in the vertical Z direction, so a negative value means the slab is displaced in the opposite direction of positive Z, which is downwards. To view the deformed shape for the live loads in place of dead loads, go to the Display menu, and click on Show Deformed Shape. Here you can change the load case from dead to live, and click on Apply to view the corresponding displacement. Similarly, you can choose a load combination to view the deformed values for that particular combination. Click on Apply to see the corresponding values. Now you can also check how the slab tends to act due to the displacement. click on the 3D option in the toolbar. Then click on Start Animation, and you can see the action of the footing due to the loads. Please note that the displacement varies in millimeters. The animation shows the variation with millimeters only, although it looks like a huge displacement. Click on Stop Animation, and go back to the XY plane. After analysis is complete, you can go for the design check. Go to Run, and click on Run Analysis and Design. After that, go to Display, and click on Show Punching Shear Design. The punching shear capacity ratio is shown as 0.2598 here. You might get a different value due to differences in assigning properties. Do not worry, just understand the process, and you can later do it yourself. The punching shear capacity ratio is the ratio of maximum shear carried by the footing to its capacity. This means, if a footing is subjected to a shear which is more than its capacity, then it will fail. This will happen when the punching shear ratio value is more than 1, where the numerator, that is maximum shear, is more than the denominator, that is the shear capacity of the footing. Thus, a punching shear value more than 1 would mean that the footing has failed, and you have to redesign it. Here the value is less than 1, which means the footing is okay for use. So the design check has successfully completed. In the next video, you will learn to interpret the results of the analysis and design. You may save the file now, and close it, if you want to continue with the next video at a later point of time. Thanks for watching.